So I'm going to do the same thing that I did last time. I'm just going to continue. I'm going to do this review first of the solution. Then I'm going to do some quizzes. I think this one is basically the same thing as the other one, but it allows you to select what kind of strategy you want. You want to grow. I assume it's probably very simple. It's just matching based on whatever strategy you have, I guess. And that's gonna determine how you grow the buffer once you hit the capacity. It seems to be the same here on the initialization. With capacity, basically the same thing as well. I think that this is probably slightly different than the other one, if I remember. But maybe it's the same thing. It creates the real one, uses this as the buffer. And the main difference is this thing here. So they are doing by default to initialize as double. Assume that's something that to be honest, this one is not very interesting to me because I think that like there's probably not a lot of things that I'm gonna learn. And already like you can already use the vector from the standard library, so probably better to just go fast through this one and not add anything. I was gonna say that either you can accept as an argument this and then make. I wonder if you can. Oh, I can't use the Vim bindings here. So, I wonder if you can do something like this and then make it equal to double by default. I have to check if it works on the other project. So, like this is a temporary project that I created just to see if this compiles. Yes, it doesn't. Maybe this is a good thing to ask GPT. Just asking ChatGPT if you about the default arguments in Rust. How does that work? If you can do it or not. Also, they're basically understand now. They have this other function, so you can initialize by passing this strategy. But obviously, it would be more convenient if you could do something like this. I think it's basically like it's very easy to understand the rest. It's the same one that I reviewed, like this, basically the same class or same struct that I reviewed last time. This is an interesting one. As far as I understand on Rust, this option here is something like it wraps the type on another type, and it allows you to check whether or not it is null. So this concept, I asked this ChatGPT as well, which other LLMs I think, but it's basically the same concept as a monad, which is something that sounds a lot more complicated than it is. It's basically a map. Whenever you have a type that encapsulates another type, the easiest way to think about is like a box where you put, let's say you have a cat inside of a box. And a monad would be something that allows you to swap the cat for another animal or for any other thing, but then maintain the structure of the box. Well, that's basically what it does here with the option. It wraps the type to give it more functionality on top of it. And I think it's used on Rust to allow you to check whether or not the value is num or no. So it's pretty interesting that you can use this to unwrap here. Like, because then it essentially allows you to have this double as the default whenever nothing is passed here. Yeah, but I guess you still have to pass none. But it's not gonna allow you to call without any arguments. And the other monad on Rust is the result type. It's basically the same concept, but I think the results is just for structs. And the purpose of result is to return either an error or okay, I think. So it is basically something that I think on Haskell you have the same kind of thing where you have the IO monad. So it basically wraps the type into another type and allows you to carry the side effects of these exceptions and errors, I think. Or in the case of Haskell, it's probably the standard input output. Here is kind of different than the other one, I think. Actually, I can see here very easily. I think on the other one, yeah, it didn't have this. Just used the capacity right away. So here they are allowing you to reserve any arbitrary value you want. But I think it's pretty similar to the capacity. But there, here it adds to the length. And then calls next capacity. It's slightly different because I guess you can the way that the buffer is gonna grow is gonna depend on the strategy you selected there. You initialize the class. So that's why it's probably slightly different. Yeah, but this part is gonna be basically the same as the capacity of the basic vector. Basically exactly the same thing. And this one is the one that I had to replace. So I don't remember exactly the syntax, but I do remember that I have to decrease the length inside of the loop and I have to use a while loop, I think. But I don't remember really well how it worked. And the reason why you have to decrease the length inside of the loop is because if you get a panic inside of the one of these drops that you're doing here, then you're gonna have the wrong length or something like that. But it's not that this is very. It's kind of like a memory leak pattern, where if you do this and then you panic, you're gonna have a memory leak. I think. I'm not 100% sure, but that's what ChatGPT said. I think it kind of makes sense, but it's not something. It's not that big of a deal. So I don't remember. Maybe it's like this, something like this. Then you just copy. Something like this. I don't remember really well. Also, it's basically the same thing. Almost just makes it different than 0, and I made actually this one the wrong one. That should be like this. Yeah, but it makes more sense, sure. Something like this. Then it would be the same, I think. Hmm. Not sure if this is correct as well. Maybe this one is incorrect. I did this one last time. It's because it's using a different buffer. A different pointer. Actually, I'm not really sure. I think this one might be incorrect. Because it may check if it. Pretty sure I checked if it compiled before. May have forgot to do this. And it doesn't make sense because like where would they come from? I guess this one makes sense. The reason why I'm thinking here is because I remember that on this previous one, I had a doubt that it was adding by the length, and I thought that it should add by 1 instead. When after you add an element, it adds the length to the pointer. And the reason why it does that is because the pointer points to the beginning of the array, so it makes sense to add the length. So that's the thing that is confusing me here, because obviously is adding 1 or is adding the index. But I guess it's the same thing because the index is going to be the current place. Yes, I think makes sense. On the other one, but actually, oh yeah, I think this is correct. On the other one, uses the length because it's the limit, the current limit of elements you have. But then here is obviously going to use the index because it's the current. It's basically the same thing, it's just a different situation. So I think this one makes sense. So I'm gonna delete this, copy this one. No. Hmm. That's because the other one was a for loop. Hmm. So maybe it should be the length actually. Because essentially it's the same thing. Because you're decreasing the length by 1. Or actually, no, because then I wonder if it matters. But if I did it like this, then it would go from the end of the thing, I think. And then it should probably decrease after. Hmm. But I think that this one, like if I want to do like this, I have to decrease after. I'm not really sure. And then you would start. Maybe this is better actually to drop the last elements first. I'm just gonna leave it like this. Whatever. I feel like asking ChatGPT about this as well. So it's basically very simple. I'm gonna mark this as done. Wonder if I do one more before doing quizzes. Slice and views. I think that as it gets more to the higher numbers, it's gonna be a lot harder. The red black tree is very hard, and some of these are probably very hard as well. Basically the same thing as the other ones. I wonder what is testing here. It grows by 2, a double. It's exactly the same thing. The drop is the same. Just gonna delete. Here it's using the reverse. I assume that this reverses the. It's kind of. It creates a range between from 0 to this to the length. Then it reverses. So it's gonna start dropping from the end. I drop elements in reverse order, not in zero force. Matches as the yeah. So my intuition there was correct on the previous one. Hmm. Wonder if I leave this one. I guess I can do the same thing as well, and then just decrease. Actually, I'm not sure. Maybe this is a good question to ask because I remember on one of the quizzes there was something about this where I don't know if it's an ownership issue or something like this, but like changing the value of the thing that is being used to loop over. I'm gonna ask this before I do this. I'm going to see if it compiles like the default version compiles. Okay, it compiles. I'm gonna test this thing that I'm talking about. It still compiles, but I'm not really sure if this is an issue or not. So I'm gonna ask GPT this one. I think it's only a problem if you do it with vectors. I think that's the issue. Because then obviously, like if you're looping over a vector and then you push something to the same vector, then you're gonna change the memory you're looping over. And I think that's obviously where if they allow that, then it's kind of bad. Because it can lead to undefined behavior, I think. think probably what Rust does is just uses the, if you don't use a reference to loop over something, Rust is just gonna use the value. So it's gonna take ownership on the loop and then it's gonna drop after that. I think that's what happens. But in the case of the vector, it's still kind of confusing. Okay, so it's recommending to decrease the length here. I'm gonna change on the other one too as well. I think I can see why this will be recommended, but I don't know. The other way it also seems that it would make sense because you only wanna say that the length has decreased once the element is no longer there, I think. But yeah, I don't know. Also, the explanation there is not very satisfying, so I'm gonna push a little bit more. Yeah, that's what I assumed. I think that makes more sense. It makes more sense to not compile. There's more on this example, I think. This thing about the output's kind of weird to me as well. I'm not sure if I understand very well. Like, why is this used? I think you might have to do something with ownership or something like that. If it allows you to return the reference to the current thing, to the current struct. There's something like this. So what I assume is happening here. So it's getting this self dot pointer is gonna be the address of the beginning of the vector. Then it transforms as a raw pointer using this as pointer. Then as the index you wanna check. Then it dereferences, I think. Actually, no, I think that it dereferences, so it gets the value, not the address, and then it turns into the address again. I'm not really sure why. It seems kind of weird. So I'm gonna ask that to ChatGPT as well. Because if you're gonna dereference, then why make it a reference again? Didn't you have the address to begin with? Might have to do the type here. Or something like this. I don't know if I can go. Yeah, I can't go. I'm gonna compile because I wanna show the pointer. The fundamental type, I think. I can't go with F12. So never mind. It's probably because I don't have the Rust analyzer. Let's see if I on VS Code. See if I add the Rust analyzer, it's gonna allow me to press F12 to go to the definition. We read this GPT response. That also makes sense. So GPT is saying that when you move, when I think it was a value, when a value is moved, it doesn't delete the memory. It just transfers the ownership of the memory to something else. So in this case, on the loop, is gonna create under the hood. What the compiler does is create a iterator struct probably that has default traits, and then it moves the ownership from the original variable to this iterator trait. So it's the same place in memory, but the iterator owns it, which means you can't do anything with the original variable anymore, I think. Maybe something that should be interesting to do is to study these built-in types, the iterator and stuff like that, to understand them. Maybe a good exercise would be to copy them, copy the types, the built-in types, and then just do the same thing that I'm doing with the other exercises, which is to remove some parts of the implementation. Then you force yourself to build it yourself, like small parts, until you understand the logic behind it. I think I might do that actually. We're probably gonna do this off stream, but I think it's only worth doing that once I go over all the other data structures. Probably. This sounds interesting, but not sure if it's gonna break the flow. Let's see. I have to. I actually don't like these things in like a shadowy thing because it makes it very confusing to understand what's going on the actual code. But you can disable. There's a keyword in the settings there. You can disable this stuff. This is something that is difficult to understand on Rust sometimes as well. Because sometimes you only have the function kind of like a function declaration without the definition inside of the trait. I think this is a trait, or here it's probably. It seems like it is on the global scope. So kind of weird because you don't know what happens or where is this defined. I guess if I try to go through here maybe. There is no weird. I think I'm gonna go more in depth. This is soft string. But this one is is this type here. So from what I understand in Rust, there's actually different implementations as well, I think. So this is a different one than the one that I was looking at before. But Rust implements the pointers as this. It does this implementation for the pointers as a generic type. That's how it knows. Probably that's how it knows how to do operations with the pointers. So this is a different one than I was seeing before. I think I was seeing this one, pointy size. Oh, it was a different one. Yeah, whatever. Yeah, whatever. So, forgot what I was gonna ask. I was gonna ask about the index. There's two things that I was gonna ask. The acquire the underlying mute pointer. So it returns this type here. I think this is the type that I was press F12 there. But it's basically, I think, is the built-in generic mutable pointer. So whenever you have a pointer on Rust, it's gonna work basically like this type here does. And then they implement functionality on this pointer through the traits, I think. Obviously, I couldn't find the definition of this. Yeah, so this is the one I think. Actually, this is not the one. Because I think this is a different kind of pointer. The one I saw last time that I was going over the code was just a simple generic pointer. Yeah, it was this one actually. So I assume that this is the default pointer, mutable pointer in Rust. Implementation for the mutable pointer. I'm gonna read this again, but I'm just gonna do some quizzes and then stop streaming. Then I'm gonna continue a little bit, probably off stream. So I think that it has to be this one, but I'm not really sure. I think what this is asking is why the type parameter is here and not here, or which one is correct. It is from the Rust book, so it's probably like there is parts that are not here, I think. Definition of that, right? Column best describes by type by RJS. Type parameter that's right. So it's asking why this is a type parameter of the trait and not the function. Yeah, so I think that what this is saying is if you have this type as the function parameter, then you wouldn't be able to assign it to the self. So you couldn't define the kind of type it is, I think. Not make much sense because add will not have any information about the structure of that. Yeah, I think that makes sense. Whether the program will pass a compiler process. Okay, so far it seems that it passes here, I think. And this one, I don't know. It's getting the address of the first value. I think that the square brackets operator dereferences the thing, so it gets the value. I think here it gets the value of the first element and then it gets the address. Then it typecasts as a const pointer, and then it's pushing here. I think it. Not sure. I think it doesn't compile. Not sure though. Because now n is gonna be a pointer to. Yeah, but it should be a const pointer, the first value. So, but I think when you push here to the vector, this becomes undefined behavior to dereference this. So I think that for that reason, it's probably it doesn't compile. So it's saying that it does compile, but it's dangerous. That has enough capacity such that v push 4 does not resize it. Ah, that's the reason. Because if you resize, I assume that you could change the memory. So as long as you don't resize, there isn't a problem dereferencing the first. Yeah, that's one. I have no idea. So obviously, I think that is not 32. Probably something else. So this one goes on the heap, and this one goes on the stack because this one is a vector. This one is an array. I have no idea. Assume like 4 and 6 or something like that. Oh, there's 3 values. The capacity is probably 4. Actually, maybe not. Maybe it's 8 because it's double. Hmm. I have no idea. So I'm just gonna guess. 16, 24, and 4. I thought that it was 8 because the capacity would be double the value, but I guess it only changes when you push another element probably. That's probably why it's 4 on the last one. So each app32 is 4 bytes. That makes sense because it's 32 bits, I think. 4 bytes. Hmm. The vector is 24 because it has a pointer. Yeah, pointer to the heap, so 8 bytes. Plus 16, which is the same as the other one. That makes sense. The variables S3, blah blah blah. Hmm. I think that S3 has more bytes than S2. Because obviously it's gonna be a pointer to actually maybe not. Because a string is slice and S2 is a string. But then I wonder like this creates a range. So it's a reference to a range, I think. It says that is a string slice. But I think that is actually this one. Simply because this is a string and this one is a string slice. So a string has the length, I think, and is on the heap, and the string slice is on the back. So I'm gonna guess this one. The string slice has the pointer and the length. I thought it was the other way around. Yeah, I don't want to ask GPT, but if I can. Interesting. The string slice is the one that has the length. Next one. I have no idea about this one. It may be dynamically sized, cannot be cast. Like, literally seems to be the B, but I have no idea. Not sure what this means. Dynamically sized. Be cast shot rate object. Yeah, I have no idea about this one. If that makes sense. It's saying that display must live longer than the vector. Obviously, so that you don't have dangling pointers, I think. Casting box, obviously, you push. It's object limit. I'll live with the vector. Okay. I did this one already. I think it drops here. Probably 1, 2. Drops here. Maybe this was a tricky one. And maybe I think this is true one actually. Because it has the lat. Yeah. So it drops immediately when you don't have the lat. When you have the lat, it's gonna wait until it goes out of scope. Yeah, I'm gonna stop here. So next time I'm probably gonna continue to go over the list here. I'm gonna do this off string probably the rest of this one. Just ask ChatGPT some questions. The next time I'm probably gonna continue on the list here. So see you then.